Hello, it is the Tuesday afternoon or evening or night math club here. We're watching the video that will teach us how to solve a system of equations with matrices. It is going to be viewed on the 12th of January 2016. This is one of the uses for matrices that you've probably seen before, but I will bring it back to mind. And what we're doing is we're taking a system of equations and we're going to take a 2 by 2. So this is going to be an x and a y that are unknown. We'll add z on the next example. So I want to solve that system of equations with matrices. You could teach a computer to do that. And I want to remember from a simpler days when if I had 6 times some unknown, say a, and it equals 12. Let me move the 12 down. 12. When I solve that, one way of thinking about it is I can multiply the 6 by the multiplicative inverse of 6. And then I can multiply this side by the multiplicative inverse of 6. So that creates a 1a, or just an a, on the left, and 12 times 1 6 is a 2 on the right. So that's the idea with matrices as well. We're going to find that multiplicative inverse and multiply both sides by it, just like in the numbers in the simpler algebra problems that we've seen. So let me set this up. Alright, I'm going to take the coefficient matrix. Remember that word coefficient means the numbers in front of the unknowns. So when it's nothing there, we call it a 1, then a -2, 2, and a -3. And I'm going to put in the unknowns in this problem in a matrix that looks like that. It's a 2 by 1. It's a 2 by 1, and it's going to equal a 5. I'm going to leave a space there, even a bigger space when I really do it. A 5 equals 5 over 10. That's the constants. So you see when I'm setting up this matrix equation. So there's actually an equals sign. And what I'm going to do is I'm going to take, if I call this matrix A, I'm going to figure out the inverse of A and multiply it on this side and multiply it on this side as well. When I do that, we know when we multiply an inverse times a matrix, we end up with the identity matrix, which in the 2 by 2s looks like that. And when you multiply that times anything, you get the identical thing that you started with. So once we get this matrix, this side will simplify to just x and y. Over here, we're going to have a matrix in here to multiply this times this, and that will be our answer. So that's sort of a skeleton sketch of where we're going. But before we can go very far, let me make this larger so I can actually fit a matrix in there. Before we go any further with this strategy, we do need to find the inverse, the matrix, the inverse of this one. And if you recall in your training, so I don't know what A inverse is yet, it's going to be the constants 5 and 10. So let's go over here and figure out the matrix inverse. So let's say, here we go, I'm going to give the matrix 1 minus 2, 2 minus 3. The process, I'm going to apply the process to this matrix that will cause me to find the inverse. And what we learned about 2 by 2s, find the determinant. Remember, the straight line means determinant. These brackets mean matrix. So I'm looking at the determinant. I'm going to need that. And so I'm going to go south, get a -3, go north, it would give us a -4, but going north we change the sign, so it's a -4. We add those and we get a 1. So that's nice. We learned that we always put 1 over the determinant times a special rearrangement of this matrix. If you recall, we switched these two. So the -3 and the 1 change places, and these take on opposite signs. It looks like I switched them, but I really didn't. I'm just changing the sign of this one and the sign of this one. Alright, so that'll be a little more obvious what I did there on the another example. So the determinant here is 1, so 1 over 1 will not affect the matrix here. So this is the inverse matrix, and now I need it back in this equation here. So during the setup I indicated that I needed the inverse matrix, -3, 2, -2, 1, and I will also, it's an equation, so if I multiply this side of the equation by something, I have to do it also on this side. Alright. If you check the multiplication out here on the left, you will get the identity matrix. The identity matrix times xy will give us xy. Alright, this side we have a 2 by 2 and a 2 by 1. So we're expecting a 2 by 1, 2 rows, 1 column. So just that many. So when we do this multiplication, this element is the first row, first column. It'll involve this row and this column. -3 times 5 is -15, plus 2 times 10. So we end up with a 5 in this element's position. And then -2, this one is the second row, first column. -2 times 5 and plus 1 times 10. Gives us a 0. So that tells me that x is 5, and y is 0. So I can write it like that. Alright, that's how you use a matrix to find, that's how you use matrices to solve a 2 by 2 system of equations. Alright, let's graduate to a 3 by 3. Find some more paper. Alright, let's do this one. And I think the highest I'll ask you to do is a 4 by 4, but the one I pick has lots and lots of zeros, so alright. Alright, here's the 3 equations, 3 unknowns. So the answer in the end will be an ordered triplet, an x value, comma y value, comma z value. So let's set this matrix equation up, and then we'll find the inverse that we need. So first of all, I look at the coefficients, and I come up with that matrix. It's a 3 by 3, 1, 1, 1, 3, 5, 4, 3, 6, 5. So that word coefficient is always the number in front of an unknown. Then we're looking for x, y, and z. And it's going to equal, I'm going to leave a space this time. Hope it still fits in. I'll make sure it does. 0, 5, 2. Alright. 0, 5, 2. Now, the strategy, like any equation, is to get rid of this and get the unknowns by themselves. So I'm going to multiply If this is matrix A, I'm going to multiply by the inverse. And the same on this side. I'm going to multiply by the inverse of A. I'm not going to take time on this video to show you how to get that inverse in its entirety. But what you do is you start with the matrix whose inverse that you need, and you augment it with the identity matrix, which looks like this, with all zeros except the ones on the diagonal there. So then we're going to use row operations to create reduced row echelon form, all ones and zeros. So in the end, this will look like this, and this side will take on the values of the inverse matrix. So it's pretty cool. So let me do like a step or two, but then I'm just going to take us down to the answer. So if I start with this one, I want this value to be a 0. So I'm going to do row 1 times minus 3 plus row 2 replacing row 2. So I'm going to rewrite rows 2 and 3 and unchanged, and negative 3 times row 1 plus 3. Oops, that's the one I'm replacing. Sorry, I was looking at the timer. I think I need to, I'm supposed to put row 1 in and row 3, changing row 2. So negative 3 times row 1 plus row 2. Negative 3 times 1 is negative 3 plus 5 gives me a 2. Negative 3 plus 4 gives me a 1. Negative 3 plus 0 gives me a negative 3. Negative 3 times 0 plus 1 is a 1. And negative 3 times 0 plus 0 is a 0. All right, let me start the rest of this on part 2.